Alright, section 4.5, summary of curve sketching. Yeah, this is an important section, okay? So actually, we're going to follow up these steps to do the sketch, okay? So let's look at these steps. First, for any given function, we're going to look at what is the domain for the function. This is the first step we need to check, okay? We need to find out for what values of x that it makes the function satisfies, okay? And for what x values that we have to get rid of because those x value does not belong to the domain. Secondly, we need to check out the intercepts, okay? When we are mentioning intercepts, that means what? Both x and y intercept, okay? So in order to find the y-intercept, what should we do, guys? Y-intercept is when the graph intersects the y-axis. So we need to let which variable equals 0, x or y. We're going to let x equals 0 because to find the y-intercept, okay? The x-coordinate of the point is 0. So we let x equals 0, find y value, it gives us a y-intercept. And how to find the x-intercept? Let which variable equals 0? Let y equals 0, solve for x. Okay? Well, similarly, let x equals 0, solve for y, that gives us the y-intercept. Right? So these are the intercepts. Alright, third step, symmetry. Do you still remember when we learned this in chapter 1 where, let's review about the symmetry, okay? So, when do we say a function is symmetric with respect to the x-axis? For the symmetry of a function, we only talk about 3 cases, okay? The first case is when what? A function is symmetric with respect to what? Y-axis, okay? So, symmetric with respect to what? Y-axis. This is one case, okay? So when a function symmetric with respect to y-axis, if the function is what? Even function. That means if we replace the x from a function by negative x, f of negative x must equal what? F of x. So this function we call it is what? Even function, and then the graph of the function is symmetric with respect to what? The y-axis, okay? Symmetry, okay? Well, there's another type of the symmetry called what? Symmetric with respect to what? Origin. O-R-I-G-I-N, okay? So, if a function satisfies f of negative x equals negative f of x, this type of function we call is what? An odd function, okay? Odd function's graph is what is symmetric with respect to origin, okay? Alright, so these are these 2 types, okay? If a function does not satisfy either of these 2, neither of these 2, we call there's no symmetry about the graph, okay? Either symmetric with respect to y-axis or symmetric with respect to what? Origin. You may ask, how about symmetric with respect to x-axis? No, okay? For function, there's no symmetry with respect to x-axis. Why? Because if the graph of a function is symmetric with respect to x-axis, can we say this is a function? No, because for one x there will be what? 2y corresponds to the same x, so it's not even a function, okay? So for a function f, there must be only 2 symmetries with respect to y-axis or with respect to origin or neither, okay? Yeah, so these 2 or neither, okay? Alright, so we'll talk about that soon, okay? Step number 4, asymptotes, okay? For asymptotes, there are two types of asymptotes we need to know. One type is what? Vertical asymptotes, right? Vertical asymptotes. How to get a vertical asymptotes? Do you remember? If we have a fraction in the function, we let the denominator equal 0, we solve that x values, right? Then we let x equals that value, give us a vertical line. It will be the vertical asymptotes, okay? How about horizontal asymptotes? How to find horizontal asymptotes? Let x goes to infinity or x goes to negative infinity, find the limit of the function. It gives us what? Horizontal asymptote. Okay, I'll show you in detail, okay, later. Alright, step 5 and 6 and 7. We are more familiar with these 3 steps. Why? Because we just learned what? Section 4.3, 4.4 about what? Intervals of increasing and decreasing for a function, right? How to find the interval of increasing or interval of decreasing for a function? What do? Find the derivative of the function, right? And then the interval that makes the first order derivative of the function positive give us increasing graph, right? And then if y prime is less than 0 or negative, has negative sign, then we say f decrease on that interval, right? And then if the y prime change signs either from positive to negative, we have local maximum, or from negative to positive for y prime, okay? This is y prime greater than 0. This is y prime less than 0. This is y prime less than 0. This is y prime greater than 0. We may have local maximum or local minimum here, okay? And then the concavity and inflection point, we should check what? Yeah, for increasing, decreasing intervals, we check y prime. For concavity and inflection point, we check what? Second order derivative, y prime prime, okay? And then the interval makes y prime prime positive, give us what? Concave upward function. Y prime prime less than 0 give us what? Concave downward graph on that interval, right? And eventually, step 8, combine everything, we can sketch the graph of the function. Okay? Any questions about these steps? This is origin. Oh, my handwriting. Can we start the first function? Terry? Where are you staring at?
Oh, I was just copying it. Y double prime.
Oh, yeah. This is y double prime positive give us concave upward.
Yeah.
Y prime prime less than 0 give us concave downward. Okay. All right. So let's try the first function. Okay. All right. Oh. It's not focusing. Uh-oh. Okay, there we go. Alright, sketch this curve, y equals x over x minus 1. Let's follow these steps and then graph this function, okay? So what is the first step, everyone? Find the domain of this function. What is the domain of this function?
Can be 1.
Cannot be 1, right? X minus 1 cannot be 0, so x cannot be 1, so domain should be all real numbers, so d equals all real numbers, but x cannot be 1, right? So this is a Saint-Beuder notation. Or you can say all real numbers except the number 1, okay, when x equals 1. Or you can use two intervals, negative infinity to 1, union 1 to infinity, either way, okay? Right? This is a pair of bases. All of the x values, this vertical line tells us such that x cannot be 1, right? Alright, step 2. Find the intercepts. How do you find the intercepts? Just now we already reviewed. In order to find the y-intercept, we let which variable equal 0? Let x, right? So let x equal 0. When x equals 0, y equals what? 0 over negative 1, right? So y equals 0. So 0, 0, this order pair give us what? Y-intercept. Right? Alright, to find x-intercept, what should we do? We should let y equals 0 solve for x. So we're going to, let me check. Okay, yeah, so focus, still work. Let y equals 0 and solve for x. So what we do is, if y equals 0, that means x over x minus 1 equals 0, right? And what x values will make x over x minus 1 equal 0? This one implies what? What kind of x value will make x over x minus 1 equal 0? A fraction equals 0. The numerator has to be 0 because 0 divided by anything equals what? Any non-zero number gives us 0. So if the fraction equals 0, numerator has to be 0, right? So put these two values in order, give us 0, 0 will be the x-intercept. Oh, both x and y-intercepts are origin, right? You guys, can you follow me? Alright, step 3. Check symmetry. How to check symmetry? Replace the x by negative x for the function and see whether f of negative x equals f of x or equals negative f of x. Okay, so let's check. Okay, this is a function f of x. Okay, we're going to, this is step 3, okay, we're going to do f of negative x. Okay, so f of negative x means when we replace every x in this function by negative x. Oh, negative x over negative x minus 1, this rewrite it. Every term on the denominator has a negative sign, pull it out. Right? Negative parentheses x plus 1. Negative divided by negative cancel out, right? So eventually this is x over x plus 1. Is this x over x plus 1 exactly equals f of x? Yes or no? No.
Can you show me the symmetry for this again?
Here.
Alright, thanks.
F of negative x equals f of x, then the function is even. Graph will be symmetric with respect to y-axis. However, it's not, right? It's not. Is f of negative x equals negative f of x? What is negative f of x? What is negative f of x? Negative f of x equals negative what? X over x minus 1. Right? So my question is this equals this? Yes or no? It's not. You see this is negative 1, okay? So let's give this negative 1 to the denominator. It will be x over negative x minus 1, right? So that should be x over what? Negative x plus 1. Is this? Are they the same? No, okay? So that means f of negative x does not equals f of x. So the function is not even. So graph will not symmetric with respect to y-axis. Is f of negative x equals negative f of x? Are they equals? No, okay? So I would say here, okay, negative f of x does not equal, f of negative x does not equals negative f of x. So the function is not what? Odd. Not either. Okay? So the graph will not be symmetric with respect to what? Origin. So do we have any symmetry for the graph? No symmetry. Okay, no symmetry means the graph does not symmetry with respect to y-axis, nor symmetry with respect to origin. So no symmetry. Okay, no symmetry. So that's good for this step. All right, now let's look at step 4. Asymptotes. To find the vertical asymptote, what should we do? There is a denominator, right? So, step 4, let denominator equal 0. We may solve for what? X equals 1. Okay, so x equals 1 as a vertical line. What is this vertical line? X equals 1. There will be a vertical asymptote or vertical line pass through when x equals 1, right? As a vertical line will be what? Vertical asymptotes. Okay? Yeah, how to find vertical asymptotes? The denominator equals 0, solve for x, and then x equals that value as a vertical line is called a vertical asymptote. You guys, we learned this before, okay? Now how to find the horizontal asymptotes? Horizontal asymptotes is when what? X goes to either positive infinity or x goes to negative infinity. We check what? The y value. So let's check. Okay, so when x goes to infinity, x goes to negative infinity, let's check the function and see the limit. X goes to infinity, everyone. Infinity over infinity. What type? We just learned this L-Hospital rule, right? Infinity over infinity type by using L-Hospital rule. We'll have another limit. However, we can differentiate the numerator and denominator, right? So differentiate x give us, differentiate x minus 1 give us what? So what is 1 over 1? 1. Oh, good. Later we know y equals 1, horizontal line will be our horizontal asymptotes, right? How about when x goes to negative infinity? We should have a negative infinity divided by negative infinity, right? Also satisfy the infinity over infinity form, right? Indeterminate form. By using L-Hospital rule, x goes to negative infinity. What's the derivative of x? Derivative of x minus 1. So eventually, what do we have? 1. So that means when x goes to infinity, y goes to what? 1. When x goes to negative infinity, how about y? Y also goes to what? 1. Later, that will help us to draw the picture. Okay, so we say, however, there's only one value for y. Okay, so we say, okay, so both of these two implies y equals 1 is the what? Horizontal asymptotes. Okay, so y equals 1 is the horizontal asymptotes. So folks, so good, everybody? Alright. Step 5. What is the interval of increasing or decreasing for the function? What should we do? Check what? First order derivative. Okay? Alright, so step 5, differentiate y. Okay, so what is y? X over x minus 1, right? So differentiate that by using what? Quotient rule, right? So y is here, okay? So differentiate y by using quotient rule will have us what? Square on the bottom. Then by using quotient rule, differentiate x times by denominator minus keep the numerator x and then differentiate the denominator, right? So what is x minus 1's derivative with respect to x? Which is 1, right? So that gives us x minus 1 minus x divided by x minus 1 what? Square. You guys? So x negative x cancel out. Oh, eventually we have negative 1 over x minus 1 square. We know that when y prime is positive, y is what? Increasing. When y prime is negative on some interval, y is what? Decreasing. However, see, we have a negative 1 over x minus 1 squared. What do you think about the sign for this thing? Can it be positive, Tyler?
No.
How about 0? Can this thing to be 0?
Well, if it was 1 there, it could be 0, no.
There's not, we don't have a 0 on top, so it cannot be 0, right? How about, a negative whole number? A negative number for the entire thing. What do you think? Yes, because on the bottom is positive, on the top is for sure negative. So negative divided by positive is what? Oh, okay. Doesn't matter what x we're choosing. We know x cannot be 1, right? So either x is greater than 1 or x is less than 1. If x is greater than 1, square is positive. If x is less than 1, the square is positive. So it doesn't matter x is positive or negative, it doesn't matter. So that means y prime is less than 0 on the entire what? Interval. So we say function y, okay, the function is what? We will say function y is decreasing on the entire domain, okay? Is decreasing on the entire domain. What is entire domain? From negative infinity to 1, union what? 1 to infinity, right? And the entire, domain, y is decreasing, keep on decreasing, right? Alright, so if y is keep on decreasing, like this, do you have a local maximum or local minimum? No, okay? So, step 6, do we have local maximum or local minimum? No local maximum or local minimum, okay? Step 7, concavity and inflection points. How to find a concavity? What do we do? Check the second order derivative, okay? So let's check. This is y prime, right? So y prime should be, we're differentiating this, right? To differentiate the fraction by using quotient rule, right? What is the square of x minus 1 squared? X minus 1 to the 4th power, right? Power 4. Then differentiate negative 1, which is constant, derivative is 0 times by the denominator minus numerator, keep it, okay, minus, this comes from the formula, this negative 1 from the numerator, and times by the derivative of x minus 1 square. What is x minus 1 square derivative? By power rule give us what? 2 times by x minus 1, right? And then times by chain rule, right? By chain rule. What is x minus 1's derivative with respect to x? 1. You guys, that's good? Alright. 0 times by square, 0, gone. Okay, it is gone. Minus negative 1 times by 2 times by x minus 1 times 1. Negative become what? Positive. So on the top we'll have a 2 times x minus 1. On the bottom we have x minus 1 to the what? 4th power, right? And can we cancel out this x minus 1 from both top and bottom? Yes. Why? Because x cannot be 1. So x minus 1 cannot be 0. So yes. So eventually, when we write this, okay, it is going to be 2 over x minus 1 to the what? Cube. This is a second order derivative of y. So how to find the interval of the concavity? What should we do? Remember? Either that y prime prime equals 0, find x value. There's no way. It's constant 2. Or that y prime prime does not exist, which is what? When the denominator equals 0, find x value, okay? So for what x value, what makes the denominator equal 0? X equals 1, okay? So if y prime prime does not exist, x will equals what? 1, okay? There's no case that y prime prime will be equal 0. There's no such a case, okay? So we can only say, oh, if the second order derivative does not exist, we'll have x equals 1. So once we have x equals 1, what do? Remember? We put x equals 1, we put a 1 on the real number line, and now we'll divide real number line into what? 2 intervals. Negative infinity to 1, and 1 to 1, positive infinity. So what do we do then? Check the key points on the interval, and then check the sign of y prime prime. Okay, so what key point do you want to choose on this interval? 0, right? What key point do you want to choose on this interval? 2, okay? So I would say key numbers, okay, key numbers, we can say, I'm going to write it here, okay? 0 and 2, okay? And then how about the signs of y prime prime? When x equals 0, plug in 0 minus 1, negative 1 to the cube, negative. 2 over negative is what? Oh, on this interval, y prime prime is less than 0. How about when x is equals 2? Plug in x by 2, right? 2 minus 1, positive, 2 over positive, positive. So that means what? On this interval, the graph is what? Concave what? Everybody? Downward, okay? And then on this interval, the graph is what? Concave upward. So we are going to get as a conclusion, okay? Function y is concave downward, or you can draw a picture like this to help you, okay? To write, okay? It's concave downward on what? Negative infinity to 1, okay? And is concave upward on what? 1 to positive infinity. Everybody? Alright, we're very happy right now because we're done with all of these checkings. Eventually, let's draw the picture. Okay, let's draw the picture. Do I have another spray paper? I hope so. Alright, yes I do. Okay, so let's start to graph. Okay, start to graph. Okay, alright, so what do you do is draw the xy plane. Yeah, you can mark on some, mark numbers on the from the system. So 1, 2, 3, 4. Negative 1, negative 2, negative 3. I really need more, okay, but it's not much. Okay. Alright. Step 1. Domain. All the numbers except when x equals 1. Step 2. Intercepts. From there, we get how many information? Just 1 point, right? Origin. Our graph must pass through this point origin. Okay? Step 3. Is this graph symmetric with respect to anything? No, no symmetry. Step 4. Vertical asymptotes, x equals 1. Horizontal asymptote, what? Y equals 1. Okay, so vertical asymptotes, let's use dashed lines. Vertical asymptote x equals 1. Horizontal asymptote y equals 1. Draw horizontal line y equals 1. right? All right, so that was the first 4 steps. Step 5, y is decreasing on the entire domain. No local maximum or local minimum. Step 7, when x is less than 1, graph looks like this, okay? Concave downward. When x is greater than 1, graph is concave upward. See? That means x is less than 1, graph downward, okay? X is greater than 1, upward. That's what we know so far, okay? From all of those 4 steps. But does this give us a picture from the graph? No. So how can we draw the picture? We have to create some actual key points, okay? So function is x over x minus 1. So let's choose some key values for x. So far we only know when x equals 0, y equals 0. But we don't know when x equals, on this side, okay? So what are those y values? So what can we try? You can try when x equals -3, compute y. Okay, let's try that. X equals -3, -3 minus 1. What do we have? -3 over -4, 3 over 4. Right, guys? So when x equals -3, y equals 1. 3/4, right? This is half. 3/4 is there. Ooh, this point is on our graph. Similarly, when x equals -2, -2 over -2 minus 1. What is the result for this fraction? What do you have? 2/3. Yeah, 2/3 is slightly less than 3/4. Okay, you can compare, okay, by using a calculator. When x equals -2, y equals 2/3. Oh, like this, like here. All right, when x equals -1, this is 1/2. Oh, okay. Yeah, right? 1 is here, okay? 1 is here. 1 is here. This is 4/3. This is 4/3. There is 2/3 in between. This is 1/2. Okay, 1/2. And then when x equals 0, y is 0. And then you can try, oh, x cannot cross the, when x equals 1. So how about when x equals 1/2? X equals 1/2. 1/2 over 1/2 minus 1. Try that, please. 1/2 over. What is 1/2 minus 1? -1/2. Give us what? -1. Okay. X equals 1/2. Y goes to -1. This point. Alright, you can try even more points if you like. However, do you see the tendency of the graph right now? See? Our graph cannot cross the vertical asymptotes. Our graph cannot touch or cross the what? Horizontal asymptotes, right? So see, is this graph decreasing? X is less than 1, yes or no? Yes. Is the graph concave downward? Yes or no? Yes. Okay. Alright, so this is when x is less than 1. We check that. We also need to find when x is greater than what? 1 on this side, where is the graph? So what do?
You can guess what it looks like.
Yeah, you can guess, of course. So I'm going to make another chart for more or you can keep on writing next to this, okay? So I want you guys to see better because it's close to the graph, okay? So y equals x over x1. I'm going to pick up when x is greater than 1, okay? Greater than 1. So I would say when x equals 2. When x equals what? I would say 3. So how about 2? 2 minus 1, right? That's what is this? 2 over 1 is what? 2, okay? So key point, 2, 2. Here, x equals 3, try. 3 over 3 minus 1, which is 3 over 2, which is 1.5. Oh, well, x equals 3, x equals 1.5, right? And you can try when x equals 4. And if you don't know what points between 1 to 2, you can try when x equals what? 1.5, okay, you can try, okay? However, what I know is, we know the graph decreases, and when x goes to infinity, y goes to 1, right? Also, when x is getting closer to 1, y value goes to what? Positive infinity. You can also check it, okay, that x equals goes to 1 from the positive and see the y value. What goes to positive infinity, okay? So, see, when x is greater than 1 on this interval, graph is decreasing, right? Also, it satisfies its concave upward or downward? Upward, okay, concave upward. So, this graph satisfies all of the previous steps, the conditions.